Hello students, in this lecture we are going to study errors of measurement. What basically errors are. You must have heard of a proverb to err is human. It means that it is the natural tendency of a human to make some errors. Errors are a part of our daily life. In this lecture, we will keep our concentration on errors of measurement. Errors of measurement basically means the error which a person commit while performing any experiment or doing any practicals. So there are many errors. In the earlier classes, while you have performed some experiment, you must have noticed that you take 4 to 5 values or readings in case of a certain experiment. For example, if you are performing Ohm's law, you take at least 4 to 5 readings of ammeter and voltmeter, and then using those readings you come to a conclusion, that is you find out the resistance of the wire that has been connected. Then why is this so that you take 4 to 5 values? Why not only one value solve the purpose? This is because there are many kinds of error, such as there may be a human error, there may be a systematic error. Systematic error means you are not going through a certain system or a certain given guidelines. The third error may be of instrumental error. There are possibilities that at some times the instrument are not functioning properly. In that case also there might be some error. So to minimize those error, what we do is we take at least 4 to 5 readings of a certain thing, and then we try to find out the error and emit this error so that we can get a near perfect value. It is not possible to get a perfect value in every case, so we try to get a near perfect value which can solve our purpose. So let's study types of error. The first is absolute error. Now what basically absolute error is? It is the magnitude of the difference between the true value and the individual measured value of quantity. Individual measured value of quantity means the measurement which you have taken while performing an experiment. Now what is true value? True value is basically the best possible value of the quantity, and it is usually the arithmetic mean of measured value of quantity. What you do is you take 4 to 5 readings and then you find out the arithmetic mean of those readings, and that value is considered to be as the true value or the near perfect value. So you find out true value by taking the arithmetic mean of all the reading which you have taken. Let's say you have taken n readings. So the true value will be given by arithmetic mean of those n readings. That is a1 plus a2 plus a3 so on up to plus an upon n. N is the number of reading which you have taken. So the absolute error, as per the definition, difference between the true value and the individual measured value. So the true value is denoted by am. So absolute value is given by delta a1. That is the error in the first reading. It will be given by the true value minus the value which you have taken, that is the individual value. The absolute value can be positive as well as negative. It all depends upon the true value. On the basis of this, we can say that the absolute error can be positive as well as negative. Second we are going to study is mean absolute error. It is basically the arithmetic mean of individual absolute error. We have discussed how to find out absolute error. If we take the mean of it, it will be known as mean absolute error. Now why it is important? It is important because the final measurement of quantity is written as A is equal to am, that is the true value which is basically the arithmetic mean, plus minus the mean absolute error. For example, let's say length is given by 4 plus minus 0.5 meter. Now what does this basically mean? It means that 3.5 and 4.5 meter. If someone find out the reading as 3.5 meter and 4.5 meter, then both of these value can be taken into consideration Reason being, I have written length as 4 plus minus 0.5 meter. Plus minus 0.5 is the error which is permissible. इससे ज़्यादा error नहीं होना चाहिए, इतना है तो चलेगा. So plus minus both, either it can be plus or it can be minus. So on subtracting I get 3.5, on adding I get 4.5. So दो इसके बीच में कोई भी वैल्यू आए that is permissible. 3.6 चलेगा, 4.2 acceptable. So all the values between these 3.5 and 4.5 are acceptable. This is the meaning of writing a final quantity in this form. Moving on, we'll study relative error or fractional error. It is defined as the ratio of mean error to the mean value of the quantity. Mean error, mean absolute error upon the quantity, and percentage error, you multiply it by 100, you will get a percentage error. Now let us understand this concept with the help of a numerical. It will be easier for you to understand. Let's say for example, the question is length of cube is found out to have values. A person measured the length of a cube and he got these 5 values. The first is 1.29, second is 1.33, 1.34, 1.35, 1.32. So these are the 5 values which he measured as the length of the cube. Now we need to find out the mean value, absolute error and the percentage error. So mean value or the true value, as we have discussed, it is the arithmetic mean of all the individual reading. Since there are 5 reading, so we'll find the arithmetic mean, which is almost equal to 1.326, or you can say it is almost equal to 1.33 on rounding off. Now what is the absolute error in each reading? So how we'll find out? We'll find out by subtracting the each reading from the absolute reading. So absolute reading is 1.33, each reading is 1.29, 1.33 and so on. So we'll subtract and we'll get all these absolute error. Once we get the absolute error, as we have discussed, you can see in the diagram, in this, as we have discussed, it can be positive as well as negative. The absolute error can be positive as well as negative. It all depends upon the individual quantity. In this case, the individual quantity was 1.34, whereas the mean value came out to be 1.33. So the absolute error will be negative. So mean absolute error, take each absolute error and find its arithmetic mean. We get 0.004. So finally the length can be written as 1.33 plus 0.004 meter. Talking about percentage error, if you multiply or the ratio of mean absolute error upon mean value into 100 will get the percentage error. So the percentage error which is permissible in this case is 0.3%. इतना error चलेगा, उससे ज़्यादा नहीं होना चाहिए. Up till now we have studied about individual error, that is error in a given quantity. Now we'll study combination of error. What do you mean by combination of error? Let's say a quantity can be found out by adding, multiplying, dividing or subtracting two quantities. Then what will be the error in that quantity? For example, area is given by length into breadth. There will be some error in length. Similarly, there can be some error in breadth. So what will be the net error in area? How to find out that? For that we use combination of error. First we are going to study error in a sum. Let x is a quantity which is given by a plus b. Delta a is the error in a. Delta b is the error in b, or the mean absolute error. And delta x is the error in x, or you can say the mean absolute error delta x. So we can write x plus minus delta x, as I have already discussed how to write a quantity. So x plus minus delta x, a plus minus delta a, plus b plus minus delta b. This can be written in this form also. As we know x is equal to a plus b, so we can cancel out them. Once we cancel out, we get delta x is equal to delta a plus delta b. It means in case of a sum, the error also add up. For example, perimeter is given by 2 into L plus B. So let's say there is some error in length, and similarly there is some error in breadth. So the total error in perimeter will be the sum of error in length and the error in breadth. Moving on, how to find out error in difference. Again, let's say there is a quantity x which is given by a minus b. Delta a is the mean error in a, delta b is the mean error in b, and delta x is the mean error in x. So we can write it in the form x plus minus delta x is equal to a plus minus delta a minus b plus minus delta b. This can be written in this form. Either you write plus minus or minus plus, it doesn't matter. X is equal to a minus b. So we finally get delta x is equal to delta a plus delta b. This indicates that even a quantity is found out by difference of two quantity, the error will always add up. It won't get subtracted, it will be added up. Moving on, now we'll find out the error in product. Let's say x is equal to give a into b. As we have already discussed, delta a error in a, delta b error in b, delta x error in x. So we can write it in the form of x plus minus delta x is equal to a plus minus delta a multiplied by b plus minus delta b. Now what we'll do is we'll take x common in this case. So we'll get x 1 plus minus delta x upon x is equal to, we take out a common, 1 plus minus delta a upon a, b common, 1 plus minus delta b upon b. Now this can be further written as x 1 plus minus delta x upon x is equal to a into b 1 plus minus delta a upon a multiplied by 1 plus minus delta b upon b. As we know that x is equal to ab, so what we'll do is we'll cancel out them and then we'll use the distribution law. We'll get 1 plus minus delta x upon x is equal to 1 plus minus delta a upon a plus minus delta b upon e and plus minus delta a into delta b upon ab. You'll cancel out 1. Delta a into delta b. Already the error is very small, and if we multiply two smaller quantity, we get a further quantity which is much smaller. So what we can do is we can neglect it. So we'll neglect this quantity as it is very small and let it tend to be 0. Tend to be 0 means it is not exactly 0, but it is very small, so we can neglect it. So what we finally get is delta x upon x is equal to plus minus delta a upon a plus delta b upon b. So this is the formula, this is the way using which you can find out the error in case of product. I will explain a numerical based on it for your better understanding. Next we are going to study error in a quotient, or how to find out error in a quotient. Let's say x is given by a upon b, where delta a is the absolute error or absolute mean error in a, delta b absolute mean error in b, and delta x absolute mean error in x. So we can write this in the form as x plus minus delta x is equal to a plus minus delta a upon b plus minus delta b. If I take x common, I get x in the bracket 1 plus delta x upon x. If I take a common, 1 plus minus delta a upon a upon b 1 plus minus delta b upon b. As we know, x is equal to a by b, so I cancel this out. Finally get 1 plus minus delta x upon x is equal to 1 plus minus delta a upon a into 1 plus minus delta b upon b to the power minus 1. Next, let us find out error in power. Let's say x is given by a to the power m upon b to the power n, where delta a is error in a, delta b error in b, and delta x error in x. So we can write this in the form x plus minus delta x is equal to a plus minus delta a to the power m upon b plus minus delta b to the power n. I take x common out of here, I get x 1 plus minus delta x upon x is equal to a to the power m. If I take a common out of this, I will get a to the power m. 1 plus minus delta a upon a to the power m. Taking b common, I get bn. 1 plus minus delta b upon b to the power n. As x is equal to a to the power m upon b to the power n, so we can cancel this out. Next, we will write 1 plus minus delta x upon x using binomial theorem as we have discussed. Neglecting the higher terms, I get 1 plus minus m delta a upon a. Taking this in the numerator, I will get 1 minus plus delta b upon b into n. Now if I open the bracket, I get 1 plus minus delta x upon x is equal to 1 plus minus m delta a upon a plus minus n delta b upon b plus minus mn delta a delta b upon ab. Since delta a into delta b is small, we neglect it. Cancelling out 1, we finally get delta x upon x is equal to m delta a by a plus n delta b by b. So in case of power, what we do is we multiply the power with the error of each quantity. So using this, we can find out the error in case of a power. Now we have discussed binomial theorem in the earlier lecture. It says that 1 plus x to the power n is given by 1 plus nx plus n into n minus 1 into x square upon 2 factorial. If the quantities or the further quantities are very small, we can neglect and we can write that 1 plus x to the power n is almost equal to 1 plus nx, neglecting the higher terms. Using this, we can write it as 1 plus minus delta x upon x is equal to 1 plus minus delta a upon a. Here, since the power is minus 1, I will write 1 minus plus delta b upon b. If I open the bracket, I get 1 plus minus delta x upon x is equal to 1 plus minus delta a upon a plus minus delta b upon b minus plus delta a delta b upon ab. As we have already discussed, delta a into delta b is a very small quantity, so we can neglect it and we can assume it to be 0. I cancel out 1. I finally get delta x upon x is equal to delta a upon a plus delta b upon b. So in case of a quotient and product, this is the way using which we can find out the error. Now using those derivation, we'll understand how basically we can find out error. So let's study some numericals. Let's study the first numerical. The first numerical says calculate percentage error in the determination of g, where g is the acceleration due to gravity, which is given by 4 pi square L upon t square, where L is the length whereas t square is the time, and the percentage error in L and T are given by plus minus 2%, that is plus minus 2% error is permissible in L and plus minus 3% error is permissible in T. Now how to find out? We need to find out the error in G, that is acceleration due to gravity. Here 4 pi square is a constant, so we have to neglect it. So we'll write delta G upon G into 100. This is the way of finding out percentage error in G. Here L and T are in quotient, so we'll write delta L upon L into 100 plus 2 delta T upon T into 100. Now why I have written 2 delta T upon T? This is because there is a power T square, T पे power है, and as we have already discussed, whenever there is a power we multiply it in the error. Second thing, it is in the form of quotient, so the formula for finding out error is delta G upon G is equal to delta L upon L plus 2 delta T upon T. Why I multiplied 100? This is because we need to find out percentage error. So as we know, percentage error in L is given by 2 plus the percentage error in T is given to be 3%, but we have to multiply it by 2. So we'll write plus 2 into 3. This comes out to be the 8%. So the percentage error in G will be equal to plus minus 8%. This is how you will solve the numerical. Now let's solve another numerical. This numerical says the length and breadth of a rectangular lamina are measured to be 2.3 plus minus 0.2 centimeter. This is the length, and 1.6 plus minus 0.1 centimeter. This is the breadth. Calculate area of lamina with error. Now as we know, area is given by L into B. So the first step will be find out the area. So area will be equal to L, take the value of L 2.3 into 1.6, we get 3.68 centimeter square. How to find out area? Since it is a case of multiplication, area will be find out, error will be found out by delta A upon A will be equal to delta L upon L plus delta B upon B. So delta A upon A will be equal to delta L, that is 0.2. So 0.2 upon 2.3 plus 0.1 upon 1.6. It is equal to 0.55 upon 3.68. So delta A upon A will be equal to this. Therefore delta A will be equal to, area is 3.68 as we have already found out. So we'll cancel out and get delta A is equal to 0.55. So finally area will be given by 3.68 plus 0.55 centimeter square. It means there is a permissible error of 0.55 centimeter square in finding out the area of the lamina. We can also find out error using the concept of differentiation. Now how it can be done? Let's see. If we come back to this numerical again, area is given by L into B, and as we have discussed, differentiation is basically small change in a quantity with respect to another quantity. So if I take this area is equal to L into B, then I need to find out error, that is the small change in A. So I can write this as delta A upon, let's say, any quantity, delta X. I'm assuming it any quantity, L into B. What is the differentiation of U into V? So first is take U as constant, differentiate the second thing, plus take the second thing as constant and differentiate the first quantity. So if I cancel out this, I'll get delta A is equal to L dot delta B plus B dot delta L. If I divide both sides by A, now using this, if you find out or if you try to solve, you'll get the same value, that is 0.55. Let's check. Let's cancel out this A again. So delta A will be equal to L. Length is given by 2.3 into breadth, that is change in breadth or the error in breadth, plus breadth, that is 1.6 into error in length, that is 0.2. Solving will get 0.23 plus 0.32, which is equal to 0.55, and this is what we got by using the formula. So by using the concept of differentiation also you can find out the error. Now coming back to this concept of finding error using differentiation, what if you have been asked to find out the error when the resistance are connected in parallel? So if you go for the formula, it is very difficult. So I'm giving you a shortcut or a formula using which you can find out error when the resistance are connected in parallel. I'll use the concept of differentiation. So if I will differentiate all these three quantities separately. If I differentiate 1 by RT, then the differentiation of 1 by X is given by minus 1 by X square dot dx. Instead of dx, I am writing delta R upon any quantity, let's say delta X. Similarly for 1 by R1, I'll get minus 1 by R1 square dot delta R1 upon delta X plus minus 1 by R2 square dot delta R2 upon delta X. All I've done is I have simply differentiated. I take out delta X, I'll finally get minus delta RT upon RT square is equal to minus delta R1 upon R1 square minus delta R2 upon R2 square. Taking out minus, I'll finally get delta RT upon delta RT square delta R1 upon R1 square plus delta R2 upon R2 square. So using this formula, you can directly find out the error when the resistance are connected in parallel combination.